Hello everyone, thank you for joining me today. My name is Malam and today we're going to be looking at the specific heat capacity practical. Okay, so now we want to actually understand the method for doing the specific heat capacity practical. Now it looks like a lot of information, well, because it is, but I'm sure by the end of this video I'm going to explain all of it and you'll understand every single bit. So now let's get right into the method. So first of all, we want to set up all the apparatus as shown in the picture. Okay, so we can see the picture over here now. What we have is a power pack off to the side. That's not really included here, in the figure, so I've just drawn it here. So that's our power pack right there. Now that's connected to something called a joule meter, and the joule meter, well, shows you how many joules of energy is being delivered to whatever component is connected to. So that would be our immersion heater right here. Now it's called an immersion heater right here because it's actually immersed. It's inserted into our metal block right here, and inside our metal block we also have a thermometer. So that's our basic setup right there. Now, then we want to read the initial temperature on the thermometer and weigh the mass of the metal block using the scale. Okay, ideally we should have a 1 kilogram block and not really need to weigh it, but we should just to double check, and we record our initial temperature because after we start heating, our temperature will change, and we want to work out how much it changes by. So number 3, turn the power pack to a joule meter. So now we start delivering power to the heater. Now, number 4, we heat the block to a temperature change of 30 degrees Celsius is seen. A couple of typos there. Okay. Why 30 Celsius? Well, that's just an arbitrary number. I picked that number randomly. It could easily be 15 or 20 degrees. But I've chosen a large temperature change just so we get a lower percentage error. Now, after temperature change of 30 degrees seen, I turn off the power pack so the heater stops heating. Then I read the reading on the joule meter, and that's the energy transferred. And then I also read the final temperature on the thermometer itself. So I can work out my temperature change here by taking the final minus the initial. That gives me my temperature change. And then all I do is input all of those numbers into my specific heat capacity equation here to get specific heat capacity in joules per kilogram degrees Celsius. Okay, so that's literally all there is, the method for determining specific heat capacity of a material. Now, we also need to be aware of some sort of error in our equation. Sorry, in our experiment. Our first source of error is parallax error in reading the thermometer. Your left eye sees a slightly different angle to your right eye. So, if you use your left eye for reading the temperature once, say your initial, and then you use your right eye for reading the final temperature, you will get a slight degree of error in your eyes just because of the way they're positioned. So one way is to just close one eye and read out, but that's not very scientific. So we can just instead use a digital thermometer with a display. So there's no parallax error in reading a display at all. Then, not all energy from the from the heater is transferred to the block. And now that makes sense, right? We can see that some of our heater is poking up out of the block itself. Not all of the power, the joules that we're delivering to the heater are being delivered to raise the temperature of the actual block itself. Oops. So instead, what can we do to reduce that sort of energy wastage? Well, we can insulate the block from all sides. This prevents energy being dissipated into the surroundings, and so increases the accuracy of our specific value. Now you understand method and source of error for the specific heat capacity practical.